So to recap, and maybe say it a slightly different way if it's helpful, we have this question: what's the probability that ax squared plus bx plus c equals 0 has no real roots given that a, b, and c are randomly chosen numbers between 0 and 1, not including 0 or 1. And it all boils down to the discriminant. When is b squared minus 4ac less than 0? Well, that's when b is less than 2 root a root c. Then, how do we find the probability? When is that true? Well, if we recognize the fact that the volume of the cube, the unit cube, which we're working in, right, because all three sides are between, all three parameters, a, b, and c, are between 0 and 1. We're working inside this unit cube. The volume here is 1 by 1 by 1 is equal to, well, that's 1. If we found the volume of space in this cube where b squared less 4ac is less than 0, we would have the probability. That would just be, think of it as the number of successes divided by the number of possibilities. Okay, so that's where we're going, and the beautiful math part is going to be setting up these limits of integration. So first, let's focus just on this. I want to know what the graph is going to look like. So let's just focus on this top part of the cube. This top part right here, and I'm gonna put it over here. This so here's right. There's a plane there. That's at b equals 1. Right. That's height equals b equals 1. And let me take this. This is gonna be sometimes it's a little bit of a leap, but I'm gonna take this and I'll show you what. Here's C and here's A. So what I'm trying to do here? It's this little arrow right here. All I did was take this plane right here and spin it up. That's right here, right? You can see that's on the C-axis, and this let's do it in red. This little red arrow right here is associated with that. So all I did was take this plane b equals 1 and put it over here. So this is, I'm going to write b equals 1. Well, what does the graph look like over here? Well, we're looking for b is less than 2 root a root c. So that's 1 is less than 2 root a root c. Here we have an equation or an inequality in two variables. But let's make it a little bit easier to see. This is 1. This is the same as 1 over 2 is less than root a root c. I can square both sides. We still have an equality. I mean, sorry, we still have the same inequality. We get 1 over 4 is less than ac, or c, and because c is our vertical axis, I want to make get c by itself. C is less than, or c is greater than 1 over 4 times a. Well, we're going to graph this, but first let's just graph c is equal to 1 over 4a. What does that look like here? Again, since we're going from 0 to 1, let's just let's look at a equals 1. I'm just going to put in some numbers and see how this looks. At a equals 1, c is equal to 1/4. So that's right here, 1/4. So 1/4. And well, we can't put in a equals 0. We're going to be a equals 0. Where 1 over 0 is infinity. But at a equals 1/4, what do we get? We get c is equal to 1/4, 1 over 4 times a fourth, which is just equal to 1. So we're going to be right there. And if you any relationship that's like 1 over x, in this case 1 over 4a is just going to be will look like this. I'm going to make it a little bit prettier. We don't really need more points on here, and you'll see why. So there's the equation of this. There's the graph of that function, but we're really interested in when c is greater than 1 over 4a, so we're really interested in this spot. So now I'm going to take this, in this area right here, I'm going to take this and put it back up in here. right like that. We're looking at this area right here. Okay, so hopefully you can see that. Make it just a tad nicer there. So now the next spot is we're going to, just like we took b is equal to 1 to find out what it looks like on this plane. Let's see what it looks like on this plane right here. And I'll do that in yellow. So what about this plane right here? This is where a is equal to 1. So we could see it projecting onto the BC plane. So let's look at that. Here's B, C, and this is A is equal to 1. Well, let's go back to this. We have B. Let me erase this just to give us some more room here. Not like that. So what is it? What is it for a equals 1? We'll go back to this right here. This, we're going to be looking for the area of b is less than, where do we say a is equal to 1? So 2 square root of 1 times the square root of c, and this is b is less than 2 root c. Hopefully I did that right, 0 to 1, right? Because we're looking at this square right here. This is the square I pulled down right there. So we're going to remember, we're just interested from 0 to 1, and b is going to go no higher than 1. So it might take you a minute, but if first we'll graph b is equal to 2 root c, and then we'll see where we fall in there. So let's take c equals 0. Well, c equals 0. 2 times the square root of 0 is 2, so b is equal to 0. So we're at that point right there. That's a point on this graph. And let's look at the other end. C is equal to 1. When c is equal to 1, b is equal to 2. So we're all the way up here. We're twice as high. We're not even in this area right here. But it's good to know that it's all the way up there, and we're gonna connect these points. But how are we going to connect them? Well, we're really interested in when it goes through the b equals 1 spot. Okay, so let's find when b equals 1. So let's look at this. When b equals 1, then 1 is equal to 2 square root of c. Square root of c is equal to 1 over 2, or c is equal to 1/4. Okay, so right here, c is equal to 1/4, and we have, make it look nice, maybe like this. And if we kept going, it would go up like that. Okay, so that's the area right here. And now we look at the inequality. We're really looking at when b is less than 2 root c. So we're really looking at this spot over here. So let me draw that. Okay, so I'm just going to take this thing that we graphed, we're going to put it right up here on this face. Isn't this fun, putting these things together like this? So that's that face right there. Okay, and I'll do the other side in just a minute, but then we're going to start setting up limits of integration.